Good morning and welcome to the 29th Annual Exhibit of Hydrogen and Fuel Cell Technology. I'm going to be brief with my introduction because we are tight with time today. There's so much new information to absorb. We're going to be talking to Dr. Nurettin Tekin, who is Hydrogen Production Management at Kawasaki, about Kawasaki Hydrogen Road Development of Innovative Hydrogen Technologies. Yeah, welcome, Dr. Tekin.
Well, thank you very much for the kind introduction. It is an honor for me to be here to present to you the so-called Kawasaki Hydrogen Road. And I guess this presentation will give you a good opportunity to have a look about what is ongoing outside of Europe. So we all know there is a big hype in regards to hydrogen, but I guess it is worth to see what are other countries doing outside of Europe, and especially what is ongoing in Japan. We as Kawasaki Gas Turbine Europe and Kawasaki Heavy Industries, I guess the brand Kawasaki is already well known, but most of the people has the one and only association, which is our fabulous motorcycles. So, but beside our motorcycles, we're doing a lot. So we are a big worldwide company, and especially in the field of hydrogen, we are quite active. So the question is, what is the so-called Kawasaki Hydrogen Road? The basic idea of this road is quite simple. It is a worldwide import of huge amount of hydrogen, including overseas transportation. Of course, Japan is an island. To implement such an infrastructure, of course, it is needed to produce huge amounts of hydrogen, and to cover this, we believe that it is quite difficult to do that only with green hydrogen. So our starting point will be Australia, based on gasification of brown coal with additional CCS, carbon capture and storage. So we import, the starting point is the import of so-called blue hydrogen. And you can imagine such an idea is, or the realization of that is quite challenging. And to do that, you have to consider and focus on the whole supply chain, starting from production, storage, transportation, and utilization. And for each link within this supply chain, we have developed a lot of different products. And when you see this picture, which gives an overview of our products, then I guess you are agree with me that this is a Kawasaki unique selling point. So we're doing a lot within the whole supply chain, and especially as the last link of the which is the utilization of these technologies within hydrogen-fueled gas turbines, hydrogen gas engines, hydrogen compressors, boilers, and other technologies also. Most of these technologies are developed directly at Kawasaki Heavy Industries. Some of them are in a joint cooperation with other companies in Japan and also abroad. Within the next slides, I would like to present you about what we have already realized before speaking about what we are going to do. So, because we did a lot, and so when we have a closer look about what we have done is, so as I have mentioned, this hydrogen road, the starting point is is hydrogen production based on gasification of coal. And on this picture, you can see next to a brown coal power plant in Australia, a first pilot hydrogen production plant. The produced hydrogen is the amount is quite low as of today. It's a pilot demonstration project, and the produced hydrogen is transported to our liquefaction facility, also in Australia, in Hastings, and after liquefaction of the hydrogen, it is transported to our loading terminal, and from this loading terminal, it is loaded onto the ship. The ship itself, the launching ceremony was already in 2019, and this ship is a first pilot ship, a small ship with a small capacity of transport capacity of 1,250 cubic meters storage volume. This ship arrives at the port of Kobe, which is the world first hydrogen receiving terminal. And this is a picture of 2020, so 3 years ago. So as you can see, we realized all this this chain until 2020, and the arrived hydrogen, I forgot to mention, is of course it's liquefied hydrogen. It's not gasified, because due to the long distance overseas transportation, you have to follow the path of highest energy density, and which is with the liquefaction of hydrogen. The liquefied hydrogen, which is arrived at this terminal, is used or can be used in this once again world first 100% hydrogen CHP power plant, which is also built up at the port of Kobe, and in 2018 was the commissioning of this unit. And you can see this liquid hydrogen storage tank. The hydrogen is gasified, compressed to the inlet temperature of the turbine, and at the upper right corner you can see the first hydrogen-fueled gas turbine. And for the gas turbine itself, the key component is of course the combustor. And for the combustors, we have developed different types. In total, 3 different combustors with different hydrogen capabilities. So the first combustor has a hydrogen capability from 0 to 30 volume percentage, and this is our standard combustor. And beside our standard, we provide 2 different combustors up to 100 volume percentage hydrogen capability. And the second one is the so-called diffusion flame combustor. This is a full flexible, this provides you the full flexibility from 0 to 100%. This means this combustor or this gas turbine can be operated with 100% natural gas, 100% hydrogen, and any mixtures of both. The third combustor is the so-called DLE micromix combustor. This is the world first DLE combustor, which is dry low emission combustor for 100% hydrogen application. In the beginning, we have developed this combustor for 100% hydrogen only, but within further improvement, nowadays, as of today, we can inject into the hydrogen up to 50 volume percentage natural gas. And this combustor is very innovative and still unique. And this combustor was awarded last year by with the Innovation Award of the German Gas Association. On the left-hand side, you can see a picture of the user control interface of this CHP power plant in Kobe. And I would like to draw your attention to the different fuel modes. As I have mentioned, we provide full flexibility in operation, and the operator can choose between hydrogen gas only, blend gas, and natural gas only operation, more or less by a touch on a button, without any physical exchange of components. On the right-hand side, you can see the main parameters of this unit in comparison for natural gas operation and for hydrogen gas operation. I guess such a comparison is quite interesting to see how, what is the difference between the two operations. And when you compare all the main parameters like electrical power, fuel input, efficiency, and exhaust gas temperatures, mass flows, then you can see there is no significant difference. So the main difference within the operation is, of course, in emissions. So the NOx emissions slightly increase from 37 ppm to 73 ppm. This is due to physics, so there is no way. So you will have always, under same boundary conditions, higher NOx for hydrogen compared to natural gas combustion. But the main point, of course, is you have a complete decarbonized system. So the CO2 amount within the exhaust gas decreases from 3% to 0. So, and with this, with this unit, which is a small gas turbine, around 2 megawatt power, electrical power, you have the CO2 savings are around 12,000 tons per year. A further advantage of our equipment is the interchangeability of the combustor. On the left-hand side, we have the commissioning in 2018 for this unit was with the diffusion flame combustor, and after successfully testing and demonstration, we have replaced the same gas turbine unit with the micromix combustor, so which provides you additional flexibility in operation. This is very important because, as of today, nobody knows how fast the market will be developed, the available amount of hydrogen, the cost of hydrogen, and so on. So with this setup, you are full flexible, and you have no investment risk. So you can operate, as of today, your unit with natural gas, and depending with natural gas, with up to 30 volume percentage hydrogen at mixing, which is our standard, and depending on the market development, you can adjust your gas turbine unit. Yes, this was in regards to what we have already done and successfully demonstrated. And within the next 2 slides, I would like to give you a brief introduction of what we are going to do. So, the first project in Europe, or one of the first projects in Europe, will be this joint undertaking between Kawasaki and RWE. And we will install the commissioning of this unit will be in 2025. So in the next 2 years, we will install at the location of Lingen the first 34 megawatt electrical output gas turbine with 100% hydrogen operation. This is one of the next projects. And another project which we will realize very soon is with our small gas turbine unit, which is in unit of one of our existing customers. It's located in Belgium, at Chevron Phillips. And there is, since 2021, the 2 megawatt unit is in operation. And this is a chemical customer. And during their processes, they have hydrogen-rich gas as a byproduct. And they have no use for that. So the hydrogen content of this gas is around 85%. But so this is, and the amount of this byproduct gas is not sufficient to operate with 100% hydrogen, but we can use it, and this unit will be operated up to 30 volume percentage. But within further steps, when the amount of this hydrogen-rich gas increase, we can adapt easily the system up to 100%. And this will be operated in August, latest September of this year. Yeah, this is my last slide and my last words. Of course, what we are going to do in a, let me say, near future. As I have mentioned, all what we did is on a pilot demonstration phase, and we will increase and scale it up as soon as possible. So the idea is to scale it up. As of today, the capacity is 2,550 cubic meters, and to build the full commercial ships with 160,000 cubic meter transport capacity for each ship. And in 2030, 2 ships are in planning. And the first ship, I guess, we can expect for 2027, 2028. So within the next latest 5 years, we have the first full commercial ship. Yeah, that's it from my side. Thank you very much. Please don't miss to join us at our booth. Thank you for your attention.